7.4, separable differential equations. Today we're going to look at the AP style of questions, and you will go to the AP classroom to complete your assignment. So you're going to see multiple choice questions that have been on the BC exam, as well as some free response questions related to differentiable equations. The only thing I'm going to do with you is walk through two examples and then cut you loose so that you can use most of your time to do your homework. Question number one, let y equal f of x be the particular solution to the differential equation dy dx equals y squared with the initial condition f of 1 equals 1. Which of the following gives an expression for f of x and its domain? So this one we've got to get a little bit more information about the domain, and I'm going to walk you through that. So let's start with our differential equation, separate the variables, always a good starting point. Then we'll want to integrate. On the right side, it's easy. That's going to be an x plus c. On the left side, I'm probably going to write this as a negative, and I said this is going to be an x plus c, so I'll get that one set. Over on the left, we want to add 1, divide by 1, so I'm going to get negative 1 over y equals x plus c. That means 1 over y equals negative x plus c, some new c. And then let's find our, oh, darn it, hang on. Let me lock that down. Let's take and find our c. I was hoping all that would move, but it's not really behaving for me, is it? There we go. All right, I got a little space. To find c, we had 1, 1 as our ordered pair. So I'd end up with 1 on the left, negative 1 on the right, plus our c. Add 1 to the other side, and it looks to me like c is going to be 2. Let's rewrite our equation. We have 1 over y equals negative x plus 2. And then I just kind of need to flip that over. You think of this as being over 1. And it's the quickest way to do it. 1 over 2 minus x. And I see there are 2 of those answers. So which one is right? X cannot be 2 or x is less than 2. Well, from what you know that the denominator cannot equal 0, correct? And that would then suggest that x cannot be 2. And it would seem like this is an appropriate answer for letter C. But the difference is when you're working with differential equations, it's either going to be, so we know the possibility of solutions are above and below 2. It will only be half of that solution. And so what I need to, it won't cross across that vertical asymptote at 2. So I go back to my original input value of x equals 1. X equals 1 sits on the left side of 2. So actually, D is our answer. I'm going to shade in D because it's kind of fun. Yeah, that's how you figure out the domain. It'll be only one side or the other for that type of domain. Example number 2, and I just remembered, I think I've got separate ones here. Which of the following is the solution? And here we're seeing, all this domain stuff again. Let's separate our differential equation. I tend to leave the coefficient over on the right side because I know I'm going to be solving for y. So I think it's a little faster to not bring the 4 over and just leave it on the right side with the x. So I'm integrating. I got 4x squared over 2. And that's going to give me y squared equals, 1/2 y squared equals 2x squared plus c, or y squared equals 4x squared plus c. And we want to take the square root, so we're going to get y equals plus or minus. Oh, shoot, we need to find, back up a step. Let's get our c value. Totally got rolling there. 2, -2, eh? So put in -2, that's going to give me 4. Put in 2 there, that's 4. 4 times 4 is 16, plus c. Subtract 16, it looks like we're looking at -12. Oh, good, I'm liking that. Equals c. Put it all back together, and we got y squared equals 4x squared minus 12. Square root both sides, plus or minus square root 4x squared minus 12. Not our domain, but our specific solution must be including a negative so that we can get -2 out of this. So I know that I must have the negative square root of this. Now, what about, how do we decide about the domain? It's one of these two, is it? Oh, actually you can tell, can't you? It's going to be C, isn't it? But why? Why is that domain x greater than 3, a square root of 3? Just in case you had to do it on a free response question. Well, I would take 4x squared minus 12 and say that it has to be greater than or equal to 0. Actually, it'd have to be greater than 0, wouldn't it? Because if I let it be equal to 0, then I would have an x value where I wouldn't need that negative, and so that doesn't make sense. So let's just make it greater than 0. Divide by 3, or factor out of 4. Let's factor out of 4. 4x squared minus 3 greater than 0. So x squared minus 3 is greater than 0 because I divided by 4. X squared is greater than 3. X is greater than plus or minus 3. And that doesn't quite make sense, does it? Let's go with absolute value of x has to be greater than 3. That way I'm going to get x is greater than positive 3. And if x had been a negative, it would be x was less than -3. That seems better. Okay, then it's going to be either this answer or that answer, and our y value, or our x value, was 2. Oh, I'm sorry. Square root, square root, square root, square root, square root. Forgot we took the square root of x to get it down to this. So this would be square root of 2. Our x value is 2, which is slightly bigger than the square root of 3. So we want the domain to be x values greater than square root 3. Alrighty. You will have a free response question. I think this is probably the free response question you are going to do. There are 4 parts to it. You will have a box in which you can put your answers on the AP Classroom, but you also can work on a sheet of paper, snap a picture, and upload the picture into that box. And that's what I would suggest doing rather than trying to type in that box. So it looks like you're writing the equation of a tangent line. You're getting a second derivative. You're answering the question, is it concave up or concave down? That's all based on second derivative, right? And then you're doing the separable differential equation, finding the particular solution. And there's part D. What happens to that solution from C as I head to infinity? So put in a large number and see where your limit goes. Then there also is another free response question. It has a slope field on it based on this differential equation, right? This says the slope is equal to, in terms of y and x, there's our rule. So do your dashed lines, particular solution. You want to write the equation of a tangent line again, not so bad. Then you want to estimate what that equation of the tangent line would be at 3, 3. So plug in, let x equal 3.3 once you get your line written and do an estimate. Find the particular solution again. So not so bad. Good luck.